Hello friends. Today I am going to discuss about industrial conveyor control using PLCs. Of course, the PLC is a controlling device. The motor is the one which is going to do the actual work. So I'm going to use a three-phase induction motor which is connected in delta connection, and this particular motor is going to be controlled by PLC through contactors. So let us begin the topic. So this is the representation of today's problem or topic. We have a conveyor, and it is being connected to the three-phase induction motor, which is going to move the conveyor forward, reverse in normal continuous mode and also in a jogging mode. So I have a switches to operate this motor. I have a stop switch and I have a forward push button which will make the motor to run continuously in forward direction, and reverse push button. So this push button will make the motor to run in a reverse direction, also in continuous manner. And also I have two push buttons here. So these push buttons are used for creating a jogging operation. So where I can have the final adjustments using the jogging operation, like a inching process. So we can move little bit forward or reverse so that you can align to exact position. So forward jogging, I have one switch, and reverse jogging, I have another push button here. So these are the total components. I am not going to discuss about this limit switches here. So let us first understand how the jogging process and forward and reverse process taking place to control this conveyor. So maybe in the next chapter or our next video, let us have a more details about these limit switches, how it is used to sense these objects, how it is going to control the motor to on and off conditions. Let us see in the next video. So here I have a wiring diagram for the said problem. Here I have forward contactor and reverse contactor. This is the power circuit, and we have a overload relay and the motor which is connected here. So the forward contactor, which will allow the motor to run in one direction, and the reverse contactor will allow the motor to run in the another direction or opposite direction. So these contactors are being controlled by the contactor coil, which is connected in the control circuit. So basically, if you want to change the direction of motor direction for a three-phase motor, if you interchange any two lines, then you can have a opposite direction of running. Say you have L1, L2, L3 for forward direction. You connect this one to U1, terminal U1, U2, or V1 and W1. So if you connect in this fashion for achieving the forward rotation, if you want to achieve the reverse rotation, so you can connect L1 to W1, L3 to U1, so that if you interchange these two or any two, so I'm just showing L1 and L3, you can have L1 and L2 or L2 and L3, any two phase conductors which you are connecting to the terminals. If you interchange, then the direction of rotation will change. So this is very basic. So accordingly, the wiring is done here. So let us try to understand how the control circuit behaves here. I have a stop switch. So this is the master stop. If I press this, whatever the operation is happening in the motor control, it is going to be in off state. So this is a master stop. I have a start forward switch. So by operating this start push button, so I can able to make the motor to run in forward direction by the help of forward contactor. So how it is being achieved, let us see here. So if I close this switch here like this, if I close the switch like this, so the current flow takes place from here to the forward contactor. So once the forward contactor gets the power, it is getting energized. So once it is getting energized, then the forward contact here will close. Also, it will close here. Okay, so once it is getting closed, then the motor gets the supply. Either it runs in a clockwise or anti-clockwise as per the supply connections which we made. So then the motor started running now. And when this contact is getting closed, the power also flows to this contactor relay or control relay. So this control relay, when it is getting energy, then this control relay contact will get closed like this. So once these two switches are getting closed, then we will achieve the latching through this path. So now by this moment, if you release your from here, the current flow would continue to go like this. It comes from here and it goes to the forward contactor continuously. So the motor keep running in forward direction without any disturbances. In this moment, if you want to stop the process, you can press the stop push button, then the motor will go to off state. So this is a forward running conditions. Now let us see how the forward, similar way for the reverse also. You can see here we have a reverse push button here. So once you operate this reverse push button, the circuit will be closed here. So the power will be reaching to the reverse contactor here. So once the reverse contactor is energized, so what happens here when the reverse contactor is energized? So here it will open. So this is one interlocking method. So when this contact is coil is energized, see here it will open. At the same time, here it will close, and also here all these three contacts will get closed. So by making this, we are ensuring that when the motor is trying to operate in reverse direction, it is already turned off in forward direction. So the forward contactor is in off state. If both are on, then it will lead to short circuit. So we have to make sure that we are turning off the forward contactor before going to the reverse contactor. So this is electronically we are achieving the interlocking through this one. Okay, and similarly we can see here forward when we are making the forward motor or contactor to energize, here it will de-energize the reverse contactor by pressing this one. Okay, so this is how it is interlocked using electronical method. So when you are giving the power, the reverse contactor is energized, then the reverse contacts are getting closed. Now again the power flow tries to go in this way to make this control relay to energized. When the control relay is energized, then the power will start flowing through this path also. At this point of time, if you release your hand from this push button, then the current flow would continue to reach this reverse contactor in this way. So now the reverse contactor is getting energized continuously because of this latching process. If you want to stop the motor, you can operate the off push button so that it will go to off state. So this is for normal mode of operation. Right. So now let us see also how the jogging operation is achieved. For jogging operation, I am going to operate the jog forward switch and jog reverse switch. So here, when I operate the jog forward switch, the contacts is going to get close here. At the same time, here it is going to open. It is going to be like this. So the power start going through this, and it reaches the forward contact, so that the forward contactor will enable this forward contacts momentarily. It is not for a long time period. It is for only momentary period or for a moment until you press the jog forward push button. So this contactor is going to be in energized state and the contacts are going to be in closed state. Right. So when this happens, the current will not go to the control relay because here it is opening here. You have to see here, it is not allowing the current to reach to control relay. Here it is getting open. When I press the jog push button here it is closing, here it is opening, so that the control relay will not get energy, so that you will not get a latching process here. So you will not get latching. So once you release the hand from the jog push button, immediately the power will be cut down like this. So when the power is cut down, then automatically the motor will go to the off state. So this is forward jogging. And similar way here for the reverse jogging. So when you want to operate the motor in reverse jogging, so you are going to operate this switch. So here it is going to move to the down state like this. So the switch comes down, and here the switch is getting closed. So when it is moving down, again it is making sure current is not going to the control relay, but the current is passing through this path and reaching to reverse contactor. So once the reverse contactor is energized, here it is getting closed, and here all three will be getting closed, and here it will open. So this is electronically, we are making sure that the forward contactor is in off state, and here we are mechanically making sure that when the forward jogging is taking place, the reverse contactor is not getting power, and when the reverse contactor is pressed, then forward contactor is not getting power. So vice versa case, it is mechanically making sure it is not latching, and also it is breaking the contacts. So this is how the jogging process is achieved in this circuit. So this is the explanation for the circuit diagram here. So let us see how it is being connected practically. This is the wiring diagram I have. So I have a Delta PLC. So this is power supply for a Delta PLC, and I have this Delta PLC unit here. So it's a very small Delta PLC, and I have the push button. For achieving my job, this PLC is more than enough. So I have 5 inputs here, so which is going to be so this is for a start forward and start reverse. I have a stop push button and jogging forward, jogging reverse. So these are my inputs. So this is my input block in the PLC, and here I have the output. So this Y0 and Y1 is for AC output. So I can directly connect the AC contactors here, and remaining two Y2, Y3, these inputs are 24-volt DC output. So I have a AC contactor. So I have used Y0 and Y1 here in the PLC block. This common is for the return path. So the power supply will go to the contactor coil, and then the return path will come to this common. Okay, so this is how it is being connected for the wiring. So how it is the power flow takes place in this path, let us see. For the switches, the current flow takes place in this red path like this. Let us take this switch. The current enters through this switch to the PLC, and then it goes here. So in the PLC module, we have an optocoupler inside. So as per the input statements, so it reaches to the common like this inside. Let us take another color. So from here, it goes to the common terminal like this inside, and then it goes to the negative terminal in this path, and it closes the circuit. So this is how the current power flow takes place in the input block and in the circuit. So this kind of connection will be called as a syncing. So the source is like a sensor, and the PLC module is a syncing type of PLC block. So actually, when we are buying the PLC, we should say what type of a PLC input block and output block we want. So this PLC block is a syncing type of PLC block, right? So for the output side, again similar way, we are going to energize the coil of these contactors. So A1 and A2, and here A1 and A2. So here the common terminal, again it is a neutral terminal. So the power goes to the A1 terminal, and then it goes to this way. It is going to Y0 terminal, and when the circuit should be closed is based on the program. When the program says the A1, this particular contactor should be energized. So here we have inside optocoupler like this. So when the program is made to close this switch, so the power which is gone to A1 will close the circuit like this, so that the path will be closed and the current return back to the neutral terminal of the supply. So based upon the program, the Y0 will be connected to common terminal, and Y1 also will be connected to common terminal. So when this is connected, so that means the contactor is getting energized. When the contactor is getting energized, we know what happens. The power will be transferred to the overload relay, and from the overload relay, it will go to the motor. So if this contactor is energized, so you will get the motor running in forward direction. And if there are another contactor, so that is a second contactor, if it is getting energized, that means you will get the reverse direction in your motor control. So now if you see here, the red, yellow, blue color code is followed for forward direction. Here the red and blue is interchanged. So here when this contactor is enabled and this contactor is not enabled, so this is off and this is on, so the motor will run in reverse direction. And in vice versa case, if this motor is on and this contactor is off, then the motor runs in a forward direction. So vice versa, forward and reverse will be done. So this is achieved with the help of a wiring, what we have done here. So hope it is clear for this wiring diagram and how the syncing and sourcing process is done. I shall remove this all. So how to write a code or a PLC program? So here I have a ladder logic which I have written already here. So as I said, I have 5 inputs: X0, X1, X2, X3, X4. So these are my 4 digital inputs which I am going to connect it to PLC. So X0 for forward running, and X1 for forward jogging, X3 for forward running, X3 for reverse running, and X4 for reverse jogging. X2 is used to turn off the machine. So this is a push button used for stop the operation. And Y0 for forward contactor, and Y1 for reverse contact. So this Y1 is a memory contactor, and this Y2 is for reverse contactor. So let us see how this simulation is achieved in the PLC. So I have a PLC simulation. Here, this is a Delta software. So I have drawn the same ladder here. As I said here, X0 is for forward running. So let me simulate from the beginning state. So X0, so let me start simulation. Run the PLC. And let me put it in the observation mode. Yeah, so now if I make this X0, that is a forward running one, what happens? You can see set on. So now Y0 is on. Y0 is a forward contactor, where this contactor, if it is energized, the motor runs in forward direction. So when the Y0 is on, it is making sure that Y2, that is here, the reverse contactor is not energized. You see here, it is opening here. So it is making sure that it is not energizing the Y2 contactor. And also you can observe here, it is latching here. Latching. So let me turn off this. You can see I turned off this switch, but still the power flow takes place through this path, and the contactor is in energized state. So the motor runs in the same direction, forward direction itself. So let me turn off the process. So I turned off the process now. Now let us see how the forward jogging takes place. So the forward jogging is achieved using this X1. So let me turn on this. The same way, if I turn on this forward jogging, what happens here? The Y0 is getting energized. So that means the forward contactor is energized. The motor going to run in forward direction. And you can see here X1, when it is energized, here the Y1 is open so that it is not going to have a latching here. So see, this Y1 is for memory purpose only. We are using this contactor. So this coil, Y1 coil, is not energized, so that you can see here it is not going to give a latching. So this is how it is differing from the normal running and the jogging mode. So now let me switch off this. See, immediately Y0 going off. Until I press the X1, the motor runs in forward direction. If I release the switch here, then immediately the motor goes up. Similarly, for the reverse motor or a reverse direction, if I set on this, what happens here? The current reaches to Y2. That is for a reverse contactor. The energies, it is getting energized. The motor runs in a reverse direction, and it makes sure the forward contactor is not in energy by breaking this circuit here. You can see this contact is breaking the circuit so that the Y0 is not getting power. That means a forward contactor is not getting power. And you can see Y2 and Y1 is getting closed here so that it is providing the latching for this coil. So now even if I switch off this, the latching path provides the electricity for the coil, and the coil keep energized, and then the contactor allows the current to flow to motor in reverse direction. So if you want to turn off the machine in this time, so you can turn off. Yeah, so this is on actually. So let me turn off this. It is not moved, sorry. So let me set up this, and I should put it here. So now we can see it is going off, right? So this is for normal reverse mode. So for a jogging mode, you can see now, let me turn on this. And before that, let me go back to normal state. So when I turn on this switch, so what happens? The Y2 getting power, and then the motor runs in reverse. But the case now here, there is no latching path provided. So since there is latching path provided, so if you turn off the switch here, then immediately the power will goes off. So immediately power goes off to the contactor. So the contactor will remove the connection from the motor so that the motor will go to off state. So this is the PLC programming for forward, reverse, and forward jogging and reverse jogging. And by doing this process, you can control the motor so that you can control the conveyor forward motion, reverse motion, and forward adjustment, reverse adjustment. Hope it is clear. That's it about this conveyor motor control. Hope it is clear. If you have any doubts, please let me know. Okay, thank you so much.